So this is my circuit. This is the input from the function generator here. Got the ground grounded with the input coming into here, which goes to the input, negative input of the op amp. This chip's actually a 4 op amp chip. It's a 741. Then I have my two capacitors. What happens is that it integrates into one. When that reaches the 10 volt or minus 10 volt threshold, that's determined by this comparator here. That then talks to the Arduino microcontroller, which then tells these two sets of switches to switch, which then allows the other capacitor to start integrating, and the first capacitor to discharge back to 0 volts. So op amp integrates into the capacitors. Again, these are my switches. Then the output of the op amp is compared in the comparator. I have two voltage dividers here and here to turn what is essentially plus and minus 15 volts into plus and minus 10 volts, so that the comparators can compare the output to that. When that threshold is reached, I get a output I get a plus 5 volts, which is read by the Arduino using the digital inputs. The code in there reads the inputs. Anytime that happens, it switches, and then it keeps track of the state, so it knows which switch is switched on and which switch is switched off, and then it knows to count up or down, which is then counted over here on the counter. So this is just a 8-bit counter with that has these LEDs here. This being the least significant digit, this being the most significant digit. The counter has both can count up and down, so you get an up signal, and you have a count signal, which is determined by code written in the Arduino. So when it gets the signal, it counts. The signal is sent out here, which then tells which switch to either high or low. If this output's high, this capacitor is the one integrating. If this output's low, this capacitor is the one integrating. So here I'm integrating a sine wave. It's a 70 millivolt peak-to-peak value with a 35 millivolt DC offset. So you can see we're counting through values here on the counter. There is a switch over here that allows me to reset the counter back to, well, it was 0, but it's now counting down. So we can see that it's counting down. If I change the offset from positive to negative, since this is an inverting integrator, it's going to count down when we have a positive offset and up when we have a negative offset. So here the offset is 0. You can see we're just kind of counting through the same values back and forth. And then as I go negative, we start essentially counting up from a negative value. Back to a 35 millivolt DC. And here we're about to count through 0, there's 0, and we're counting up again. So I've hooked up the oscilloscope here. I'm going to use this to measure the output of the function generator, and then I'm going to use this other one to measure the signal in various places. The output of the op amp, the voltages across the two capacitors, the comparator voltages and things like that during operation. Here we're integrating a 2.5 volt sine wave. That's going to be the yellow wave on channel 1. If we stop this real quick, we can see that we're integrating here. We reach this 10 volt threshold. This is a 5 volts per division, so 2 divisions up, 10 volts. Reach that, drops back to 0. We start integrating again. We reach the peak of our sine wave. We're still integrating. We reach minus 10 volts, goes back to 0. That's our switch. Start integrating again, come back up, hits 10 volts. We switch again. So we can see that it's just switching back and forth. Looking at the LEDs are just going from all zeros to 1, so it's going 0, 1, 0, 1. giving us the count. This is with a 0 DC offset. Here we have a 2.5 volt peak-to-peak square wave with an 80% duty cycle. Again, you see when we're at low, so this is going to be minus a volt, 1.25 volts. We are integrating up. As soon as it goes positive, we start integrating down. We reach our minus 10 volts and we count. So that's our discharging of our capacitors. If we change the duty cycle to 50% here, you see we get a count up 1, count down 1. We're counting down here and up here. And we go ahead and decrease that down to, say, 20%. We count up, we integrate down, we don't count because we don't reach our minus 10 volts. And the LEDs are counting up in this case. If we look at just the voltage on one of the capacitors in this case, so this is going to be the square wave with the 20% duty cycle. We see here we're integrating up, we count down, and we maintain a 0 voltage. This is while the other capacitor is integrating, and as soon as we switch, we start integrating again, and here we come back to 0, maintain a 0 voltage. So the other capacitor is doing all the integrating, so we've integrated up. Here, because we have a positive voltage, we're actually going to be integrating down since it's inverting. Here we come back to a negative voltage, so we start integrating up again. At this point here, the other capacitors reach the 10 volts, discharges and switches to this, and here we are integrating down 0 voltage, the other one's integrating. Here's an example of this long integration that occurred here on the other capacitor. So if we look at the other capacitor here, we can see the same kind of thing, integrating 10 volts with intermittent 0 voltages while the other is integrating. If we look at the output of the comparators here, these peaks are when the comparator, when we have more than 10 volts on either of the two capacitors, so it's telling the Arduino to switch. And here, this was going to be the signal that is for more than minus 10 volts, but if you notice before, we never hit that because we have a 20% duty cycle. But if we increase the duty cycle to 50% here, you see we start having those peaks. So in that case, the output is going to look something like this. Voltage going to the switches is a simple high-low here. So if we change the duty cycle a little bit, let's go back down to 20. You can see that we're switching on and off. When it's high, one capacitor's charging. When it's low, the other capacitor's charging, and the first capacitor's discharging.